Hello, I'm HK, and today I want to talk about something that's been on my mind for a while now, which is on-prem AI deployments. I've built a lot of applications where I'm using the cloud to deploy AI models, but having done and built a lot of applications, I do believe that there is a lot of scope for on-prem deployments of smaller models for various companies that would allow for lower latency, high throughput, and stuff like that. And I wanted to sort of show you guys a concept that I made for something that could help sort of gauge the effectiveness of a deployment. All right. So just imagine that you are a company that has like cameras that you want to constantly analyze. Say for example, the thing that I'm going to be showing you guys right now is where you see food in the frame. So, imagine you're a grocery store or something, or just some kind of store where you want to detect food in your videos. So, what you would do is you would deploy, maybe if you're using like a really small model, deploy that to your, Jetson Nano or whatever, and then connect that to your camera, and then, see how quickly you could sort of detect that sort of information. So, to give you an example of the like data set that I'm going to be using for this demo, I'm just going to play a quick video. So it's just like an AI generated video of this guy standing outside, looking outside, and then sitting down reading a book. So as you can see, there's food only in like limited frames. So by like even the start of the first second, you can see that there isn't like any more food in this frame. And so what we're going to be looking at here is sort of a vision model that I connected my script to, that's going to give you a lot of diagnostic information about how well the model did, and which frames it actually detected it and stuff like that. So I'm gonna go to the terminal real quick. I'm gonna open up a new terminal, and then as you can see, I'm in my virtual environment. So I'm just gonna okay, right now, so I'm just gonna Python analyze.py, and then this is called test.mp4. I think these are the right commands. Okay. Uh, Question. So I have my question in input. Okay, I just need my input, and then everything else is set. So you can see it's using my CPU, and then in frame 10 you can see that it's a yes, and in all other frames you can see that it says no. And then I have this sort of script that I generated, where it just generates like a run ID, started at, end at, so you can tell the total time that elapsed, and then you can see the question is there food in the image, right? So answer yes or no. And then I have a sampling policy of every nth frame, which is very typical if you're running any sort of like video or image detection task. You don't want to be processing every single frame because then that's compute inefficient. And you can see some really curious like metrics here, right? For example, this worked like pretty well. It was pretty quick, but the source FPS reporter, which is the number of frames per second of this video, is 24, but the actual ingest FPS, which is the amount of frames that were able to be pre-processed and then sent over to my actual model, was only 10.67, right? So if I was deploying a model, for example, this is something I'd want to optimize. You can also see like your P50 and your P95 latencies, which is basically, if you were a 95th percentile user, what sort of latency could you expect, while processing each frame. So you can see that it's about like 2 seconds, because all of this is in milliseconds, which is again like a pretty big amount. You'd probably want to reduce that if you're going for real time inference. If you're doing batch inference, that's fine. And then you have like throughput and FPS here, which is the number of frames per second your actual that was like actually given to your model, and your model like processed it. So it was able to process like approximately like 1 frame per second. But the thing here is our n over here that we used is actually 10. Where did my n go? Right. So every nth frame, right? And n is 10. So we're skipping by like 10 frames, and then it's only processing like 1 frame per second, which is a little slow. So we might want to improve that. So as you can see, there are like no errors and stuff like that, and you can see that my deployment passed, and I can run a reusable Docker command that would replicate this. So yeah, this is something I personally don't have any hardware to test this on, but it was just a simple test script that I came up with that I thought could be pretty useful for these kind of situations. So thank you.